So good morning one and all. So let us start today's class. Today we'll discuss something about feed forward neural networks, also known as multi-layer network of neurons or simply deep neural network. So this is simply deep neural network, or simply you can also call as a neural network. Now, so this is the neural network. So here we have actually L number of layers. How many? L. Okay. So if there are L layers, among them L minus 1 layers are hidden layers. So if there are L layers, there will be L minus 1 hidden layers. What about remaining layer? Is a output layer. Okay. Now, so the input to the network is of n-dimensional vector, right? So let us come here. So the input to the network is this. Okay. So what is this? Input layer. So how many inputs we have? x1, x2, so on, xn. It is a n-dimensional vector. So we can say input x equal to n-dimensional vector. So x equal to what now? x1, x2, so on, xn. It contains n elements. So it is called zeroth layer. Input layer is called zeroth layer. Okay, it is a having n elements, so it is a n-dimensional vector. Okay. Right. Next. So the network contains L minus 1 hidden layers. So having n neurons each. Right. So actually here I told you if there are L layers, L minus 1 hidden layers will be there. Okay. Now here we have how many layers actually? This is the zeroth layer. This is the first layer. This is the second layer. This is the third layer. This is the third layer. So total how many layers we have? 3. L equal to 3. Anyway, so it is simply an input. It is not a layer actually. This is simply input. So we have L equal to 3. This diagram is for L equal to 3. Okay. Now, so if L equal to 3, obviously L minus 1, 3 minus 1 equal to 2 hidden layers. So in this diagram we have 2 hidden layers. Okay. So what are they? These are the 2 hidden layers. Okay. And each hidden layer has how many neurons? N neurons. How many? N. So we have 2 hidden layers. Each hidden layer has n neurons. In the input also we have how many? N neurons. Okay. Right. Next. Yeah, each neuron in the hidden layer and output layer can be split into 2 parts, pre-activation and activation. Okay. So each neuron in the hidden layer and as well as output layer. This is output layer. Okay. So each neurons in the hidden layer and the output layer. How many hidden layers? 2. And 1 output layer. So it is split into 2 parts. What is that? Pre-activation and activation. Okay, you observe this neuron. Okay, so what is the pre-activation? A1. What is activation? H1. Okay, so for every neuron we have a pre-activation and activation. Okay, so what is that exactly? Now here this is A1, this is H1. Okay, so this is pre-activation. And this is activation. It is for what neuron? This neuron. Okay. Now, in general, for every neuron, so AI is the pre-activation and HI is the activation. So these two are vectors. Please remember, these two are vectors. Why? You observe here. We have here so in the hidden layer, so we have n neurons in each hidden layer. So this light blue region, this A1 means this vector, which is in the light blue region for all n neurons. Okay, what is A2? That is what is H1? That is this dark blue region. That's why they are vectors. Is it okay? So for each neuron we have a light blue and dark blue. So the light blue region is a pre-activation and the dark blue is the activation. So A1, H1. Similarly, AI, HI for another layer. So this is A1, H1 for what layer? First hidden layer. A2, H2 for the second hidden layer. Okay, so on, so on. Now, next. The input layer can be called 0th layer and output layer can be called 8th layer. I told you already. So this is the 0th layer. This is 0th layer. This is the third layer. Why? Because here we are taking only 3 layers. And these two are hidden layers. Okay, next. Now, so the double I. Okay, now we have connection. What is the double one? It is a connection between this input layer and the first hidden layer. Double one is a connection between input layer and the first hidden layer. What is double two? It is a connection between the first hidden layer to the second hidden layer. What is double three? It is a connection between the second hidden layer to the output layer. Okay. Now what are they? They are weights simply. Okay. Now what is W1? Actually each input is connected to each neuron in the first hidden layer. Okay. X1 is connected to all n neurons. X2 also connected to all n neurons. So on, Xn also connected to all n neurons in the first hidden layer. Okay. X1 connected to this neuron, and so on, last neuron. X2 connected to first neuron, second neuron, and the last neuron. So like this, each input is connected to all n neurons in the first hidden layer. Okay. Now obviously here, so X belongs to Rn. So before that, what is Rn? If I say Rn means it is a collection of n tuples of real numbers. Collection of n tuples of real numbers. Suppose if I say R3, which means x1, x2, x3. So here x1 can be a real number, x2 can be a real number, and x3 can also be a real number. So you can take all possible real numbers for x1, x2, x3. Okay. Now x1 is x belongs to Rn. What about Wi? W1? Now W1 is what? It belongs to Rn cross n. You get a matrix. Why? Because x1 is connected to first neuron, second neuron, and nth neuron. x2 also connected to first neuron, second neuron, and nth neuron. So like this you get a matrix form. And what is this? Yeah, these are bias vectors. These are bias vectors B1, B2, B3. Here for each neuron we have a bias in the hidden layer. Okay, B1 is connected to all neurons. B2 is connected to all neurons. Okay. Now what is B1? Obviously B1 is connected to only B1, that is connected to all neurons, which means it is a bias for all the neurons. Okay. So B1 belongs to R power n. B2 also belongs to R power n. So B1, B2 belongs to R power n. So W1 and W2 also belongs to R power n cross n. Okay. W1 comma W2. Now, so these are weights and the biases. Okay. Now, so I forgot to tell you one more thing, that in the output layer we have only k neurons, not n neurons, only k neurons. So in the input we have n inputs. In the hidden layers we have n neurons in each hidden layer, but in the output layer, or that is nth layer or third layer, we have k neurons, not n neurons. You can see very clearly from the figure. Okay. Right. Now, so what is W3? So each n neuron is connected to k neurons. Okay. Suppose this neuron is connected to k neurons in the output layer. It also connected to k neurons in the output layer, so and so. So W3 belongs to real of n cross k, because in the last layer, that is output layer, we have only k neurons, not n neurons. So B3 also connected to only k neurons. Obviously B3 also belongs to Rk. Okay. So in general, what do you say? What have you written here? So up to L between layers, okay. Double L and BL belongs to the R power k n cross R power k. So yeah. So the last layer, actually L equal to 3 now. For general, in general you can write BL, WL. Okay. So WL belongs to R power n cross k or n cross k. BL belongs to Rk. So that is, these are the W3 is the weights between the last hidden layer to the output layer. B3 is a bias to the output layer. Okay. Next. Yeah. So the pre-activation at layer I is given by. Yes. So the pre-activation at layer I is given by. Okay. What is A1? Okay, that is the question. How to get A1? Okay. So before that, let me write here. So the activation, here it is H0. Okay. Here is H0. For this H1, for this H2, for this HL. In this case H3. So the activation starts from input H0, H1, so on HL. So here L equal to 3 we have taken up to H3. Okay. So H0 means simply input. This is H0. What is H0? Simply input. So H0 equal to X. Now, so what is H1? Actually, what is this H1? Oh, okay. Before that, what is A1? Generally, what do you write A1? So let me write. So in this case, we have written. So let me go back here. So we have some inputs X0 and weight W0, X1, W1, X2, W2. Do you remember this? Now we have taken the aggregation or weighted sum. What is that? X0 W0 plus X1 W1 plus X2 W2. That is a pre-activation. So we have taken the activation. We have taken some decision. What you have done here? If so, okay, let me write here. So this also written as X0 W0 plus X1 W1 plus X2 W2. Okay. So this is we are called as bias. X0 equal to 1. So W0 equal to minus that equal to B. B plus X1 W1 plus X2 W2. This is the what? The weighted sum. Okay. Otherwise we have taken summation Xi double I plus B. This is what the summation we have done till now. Is it okay? Now remember this. Now here, so based on the summation we have taken the decision. If it is greater than 0, we have taken 1. If it is less than 0, we have taken 0. Something like that. Okay. Now here, this is A, activation. Something like activation. AI. Okay. So in the same way, what is AI in our case? BI plus WIH I minus 1 X. Okay. So AI equal to B means BI plus WI into H I minus 1 of X. Remember this. Is it okay? A I of X equal to BI plus WIH I minus 1. Why it is so? Okay. So from this diagram, so what is A1? A1 equal to B1 bias plus W1 into X. Okay. But what is X? Is same as H0. Is it clear? So from this, what we can write is A1 equal to B1 plus W1 H0. Do you agree or not? So instead of X, I am writing H0. That's it. So A1 equal to B1 plus W1 into H0. Okay. So if keep I equal to 1 here. So A1 equal to B1 plus W1 H0 of X. This is the pre-activation for layer 1. Now, so A1 equal to B1 plus W1 H0. Now, so I told you here, please remember, this belongs to R3. It also belongs to R3. So this belongs to R3 cross 3. It also belongs to R3. Okay. Now, so you have written A1 means A11, 12, 13. B1 means B11, B12, B13. So W1 I am writing, so please be careful here. W1 is nothing but it is a weight between the input layer to the first hidden layer. What is the dimension of W1? 3 cross 3. So it is W1 11, W1 12, W1 13, so on so on. Write all the weights. Okay, into H0. H0 is x1, x2, x3. So if you multiply these two, you get like this. Is it okay? Right? This is the activation. This is what? A1. A1 is a vector. H0 is a vector. B1 is a vector. W1 also a matrix. So this is what the pre-activation of layer 1. Now, yeah. So now let me go back here. Okay. So pre-activation is over. What is activation here? So let me write one more diagram here. So we have like this. Okay. So this is pre-activation. You get AI. Okay. So H I told you HI is there, but how to get HI? HI is some non-linear function of AI. HIX should be there, but is okay. Okay. So in case of sigma and neuron, what you have done? So what is this G? G is a function which is non-linear. So what have you taken? 1 by 1 plus e power minus omega x plus b. Isn't it? So like this we can take any non-linear function, that is G. G is called activation function actually. Is it okay? Hi of x equal to G into A of x. For example, logistic, tan h and linear, etc. We'll discuss all these things later. Now, so please be careful here. Now this is A3 and this is HL. For last the output what is this? What is the activation? A3 and H3. How to get A3 to H3? So H3 equal to, we write some output function of A3. In general, so we are dealing with in generality, L equal to 3 here. That's why HL equal to some function O of AL. O is the output activation function. What it is called? It is the output activation function. Output activation function. So we'll discuss various kinds of output activation function. So simply I can write it is something like this. So we have a first input layer with inputs. Let me write here x1 to xn. Okay, this is called H0, our zeroth layer. So we have a n. We have n neurons in the first hidden layer, and again n neurons in the second hidden layer, and we have k neurons in the output layer. Okay, so here we have pre-activation A1, that is this. Next we have a activation H1. What is this? This. Observe firstly, this is the pre-activation and the activation function of the first hidden layer. Next, so A2, this, h2, this. So this is Al or A3, and this is H3 or HL. Okay. So what is Hi? Equal to some function of Ai. G is called the activation function. But what is the HL? That is the final output. That is O of AL. This is called output activation function. Now, so here we got A1, A2, A3, correct? So let me write here. You take an example, right? You take an example. A1 equal to B1 plus W1 H0. So we got A11. So what is A1? Is a vector A11, A12, A13. This is the pre-activation of layer 1, A1. How to get H1? H1 equal to G of A1. Isn't it? From the logic. So G of, what is A1? All the elements. What are they? A11, A12, A13. So suppose if this function is elementary wise function, then what happens? Now H1 means H11, H12, H13. That equal to, what do you get? So you take this G inside the matrix. So it is elementary wise function. Suppose it is elementary wise function, what do you get? So G of A11, A12, A13. For example, if it is sigmoid function, what is G A13? Sigma of A13, 1 by 1 plus e power minus A13. Is it okay? So this is about activation function. So the final activation function at the output layer is given by O of AL. O is the output activation function. We will discuss what is that later. That is called HL. That is called f of x. Okay. So here HL equal to f of x equal to y cap. Okay. Finally, so HL equal to f of x equal to y cap. How to get this? So this is a predicted value, right? This is a true value. So that equal to what? O of AL. This is the what we have. We have neural network of multi-layer neural network. So for simplicity, we have taken 3 layers. So 0th layer, 2 hidden layers, 1 output layer. Okay. Now, so let us go to our model. So first we'll get a data, right? So as I told you already, this is very, very important. So we get some data. They give you input and some output. I equal to 1 to n. We have a data. So obviously, I told you there is a true relation between y and x. So there is a true relation between y and x, which we don't know. So what we do now? We assume that y is some function of x. Then what we do? We assume that y is some function of x with some parameters. We assume that y and x are related by some function f of some parameters. Okay, so we have to learn these parameters. So that what will happen here? So y will be y cap, you can also say y cap is same as y. So our aim is to learn the parameters of this function which can approximate this function properly so that the predicted value is same as the true value. Okay, now we'll get data. So now what is the model? This is a model. Okay, so here we have 3 layers, right? Okay, first, as I told you, we have pre-activation, activation of the first layer, second layer activation, and second layer pre-activation and second layer activation, and the last layer pre-activation and last layer activation. Okay, so now tell me, as I told you, H1 equal to G of A1. Okay, next H2 equal to G of A2. Now H3 equal to, that is the last layer O of A3, isn't it? Correct? Okay. Now, so this is A1. What is that? W1x plus B1. Next, we have G of A1. Okay, this is H1. Next, what do we have? W2 into H1 plus B2. What do we have? W2 into H1 plus B2. It is nothing but A2. So next we have W2 into, G of A2. What is this? So try to understand the things properly. A1, this is H1, this is H1, this is A1. Okay, next. So W2 into H1 plus B2, this is A2. And what next? This is G of A2, H2. Okay, next. So O of W3 into H2 plus B3. So this is H3 or HL. So now we are increasing the complexity so that it gets more representation power. Okay, so these are all generally non-linearities. We have increasing the non-linearity so that we get more power. What power? Representation power. Okay, so generally what you have done in case of perceptron, we have taken summation wi xi. Correct? So in case of sigma neuron, what have you taken? We have taken some non-linearity, 1 by 1 plus e power minus w transpose into x plus b. This for sigma neuron, this for perceptron. Okay, now here we have taken this one. Now, so what are the parameters? W1, W2, WL, B1, B2, B3, all biases and all weights. L equal to 3 means W1, W2, W3, B1, B2, B3. What algorithm? Again here we go with gradient descent with back propagation. We will discuss what is back propagation. Now this error, here it becomes summation I equal to 1 to n, summation j equal to 1 to k, y cap ij minus yij whole square. This is the loss function or error function or objective function. Okay, so now we have parameters of how many parameters? Now theta is nothing but W1, W2, so on WL and B1, B2, so on BL. We have to learn these parameters properly so that our approximation will be good. Okay, right. So we stop here. Thank you.